Welcome to today's webinar, Getting Started with Teleport for Building Privileged Access to Infrastructure. Today's presentation is going to be about 30 minutes long. We will have time for maybe a little less. We'll have time for questions at the end. So please go ahead and pop questions into the Q&A box. If you have any issues with anything on Zoom, go ahead and send me a chat or put a question into the Q&A box, and we'll try to get that sorted. We are recording today's webinar, and we will send out the recording to everybody at the end. Today's webinar has two parts. There's an overview first of Teleport, just providing some general concepts, and then we will get into an actual demo. And I think that's all the housekeeping. So with that, Gus, I'm going to go ahead and hand it over to you. Okay, excellent.
So hey, everyone. As John mentioned, I'm Gus Luxton. I'm a solutions engineer here at Gravitational. My role is to help customers to build and architect solutions which make their lives easier. One of those is using Teleport for privileged access management. So a little bit about us to start off. So we are Gravitational, and our mission is to empower developers to run applications securely and consistently everywhere. To that end, we have two products. The first product, which we're not going through today, but can be done at other times, is Gravity. And Gravity is a solution for creating and distributing fully contained images of a Kubernetes cluster and all its dependencies and the applications that run in it. And when we came up with that product, Gravity, we realized that it's great to be able to create and distribute a cluster image, but we also need to be able to manage access to those clusters so that people can start and stop the applications, can upgrade them, can manage them, can get logs from them, and that kind of thing. And as such, we didn't have a good way to do that. So we came up with Teleport. Now, Teleport is a privileged access management solution, which means that it controls users and identity and who is allowed to log on to systems. So it can be used to control access to your server fleet, and also to record all SSH traffic to and from your servers. It's designed on our end to make user management and administration much easier and reduce the nightmare that can come from trying to manage user access sometimes. It also records audit logs, clear and concise audit logs of what actions users took at what time and on what server. And many companies require this information for compliance and logging and security purposes. It can also be used to record traffic to and from Kubernetes pods using kubectl or kubectl, which is something that we will discuss later on. Teleport is a pretty simple product, but can also be very powerful. It can work equally well for one server or for thousands of servers. It has features within itself to group servers into logical groupings called clusters, which can have different access rules and roles applied to them and so forth. So I'll start off with a little review of standard password-based authentication with SSH. Many people may have used this. Generally, if you hire if you rent a VPC or a dedicated server from a provider, they will give you a login and a password to be able to get onto it and to install your applications and run things. So we consider, and many people consider, password-based authentication to be a little bit of an anti-pattern, something that you don't really want to do. Now, the way it works fundamentally is that when you go to log in, you send a username and you send a password. That password, as it says here, is sent as clear text, but it is encrypted over the SSH protocol. So there is a key exchange which takes place between the host and the server, the host and the client, and that password is passed over to the server. It checks the hash of that password against the local database on the server, and if that hash matches, then the server authenticates the user, Alice in this case. So it's a very simple model. Unfortunately, it is a little bit insecure. There's a number of reasons for that. One of them is because anyone who knows that password is capable of becoming Alice in this case. It's possible for passwords to be keylogged or for someone to watch you enter the password. And if that happens, then that account is compromised. And unless you have good logging and monitoring, you may not realize that that's happened until it's too late. Users, like Alice in this instance, don't always use good passwords. And if they do, then they sometimes reuse those passwords on other sites or other servers, which can reduce their security, because if you lose the password for one, you lose the password for all of them, and then all of them have effectively been compromised and have to be treated as such. If you need to change that password, then you have to change it on all the servers. Otherwise, Alice won't be able to log in. And that can be, there are many solutions which make that easier, but that can be a problem. Centralized user database, for example, could help with this, something like LDAP or a provider, as an SSO provider. But that always relies, again, on all of the updates being propagated to all of the servers, which, due to flaky connectivity or anything like that, can sometimes be a problem. So what's better than passwords? Well, you may have heard of SSH public key authentication, or the use of a key pair, a private key and a public key to authenticate yourself with a server. This is also the same technology that you use, or this is the same technology that you use for logging into an EC2 instance on Amazon, for example. So the idea here is that Alice can generate a key pair, a private key, which only she knows, and a public key, which can be given out to anybody. And this principle is used to grant access. So Alice, and only Alice, is capable of signing a message or a payload with her public key. The only way that you can use a public key to sign a message is if you also have the private key, which is associated with the public key. That's cryptographically secure. It's a mathematically validated operation, and it authenticates that in this instance, it was definitely Alice who wrote that message, because she's the only person who has the private key. If someone has Alice's public key, they validate that Alice did actually write the message, and they can do that without knowing Alice's private key at all. So here's how SSH public keys work in a traditional sense. You add a public key into the authorized keys file on a server, and when that user tries to log in, the server sends them a message containing their public key plus a unique one-off number called a nonce, and it asks them to verify their identity. The user takes that message, they sign it with their private key, and they send it back to the server. And the server can use that process, as we just detailed, to cryptographically verify that the message was correctly signed by the private key of the user who owns that same public key. In this instance, that's Alice. So if the validation is successful, then Alice is allowed to log in. Now, this is a brilliant principle. It's much more secure than passwords, or at least it can be, because the private key is something that you can hold. It's much longer than a password. It's much harder to hack or to guess. And it works great for a small number of users and a small number of servers, where it's quite easy to keep track of each user's public key being on each server. So it's generally better than a password-based solution, because as long as you keep that public key secure and you protect it well, nobody else has it, because you don't type it in. It's not keylogged. It's not entered in any way at any time. But what happens when you need to remove a user's access from a server, for example? So you need to know which public key corresponds to which identity on the server. So sometimes this can be easy if they're all named properly. You can put a comment on it saying this is Alice's public key, but sometimes that doesn't happen. And sometimes, particularly if users add their own public keys to a server, then they have a nonsense name like, generated key and the date or something like that. And that means you don't know whose key that is. And the other problem is that when you do want to revoke someone's access, you have to remove that public key from every server where it's ever been put. So if it's still present anywhere, then that user might still be able to log in, which is probably something that you don't want. So this solution, it doesn't scale particularly well at all. So what's better than that? Well, here's the idea. This is just a summary of how the authentication works. So what's better? It's short-lived OpenSSH certificates that identify individual users. So the way that works here is Alice can log into a teleport server instead. The teleport server will authenticate her and will generate a certificate. It uses a certificate authority, which is also generated by the server, and it gives that key pair to Alice. So a certificate authority is a principle which is used throughout SSL, TLS, and all kinds of other public cryptography operations. So if you ever log on to a website and it uses HTTPS, then that's also using public key cryptography, and it's using the idea of a key pair to exchange messages securely. So the public form of that certificate says this is the user known as Alice, and this certificate allows Alice to use a principal with a given name. A principal here is a Linux user, so the user EC2 user on AWS, for example, or Ubuntu or root. And they also embed the information which says this certificate expires 8 hours from this time, for example. So when Alice wants to log on to the server, she sends the username that she wants to use, and she sends the form of the certificate, the public form of that. And the server sends back another message saying, again, with a nonce, saying, are you really Alice? And if you are, you need to prove it by signing this message with your private key that you have. So Alice signs the message and sends it back to the server, and using a similar operation as before, the server can validate that that was Alice who signed that message, and that Alice should be allowed to log in. So what are the benefits of this method? Well, the only thing that the server needs to be told is there is a certificate authority issuing certificates, and you should trust all of them. So the idea being that Teleport's certificate authority can be trusted, and it will allow anyone who has been given a certificate by that authority to log in. And there isn't anything else here that the server needs to know. There's no list of public keys that needs to be tracked and maintained. There's no commenting of keys. There's no any of this information at all. All it needs to be told is this certificate authority is what you need to trust. And in this instance, another benefit is that Teleport itself is what actually decides whether a user should be granted access or not. And it can also delegate those actions to an identity provider or a single sign-on provider. And the single sign-on provider can also maintain a list of users and decide whether they should have access or not. The certificates which are issued by this method are only valid for a short period of time. I mentioned 8 hours at the beginning of this. And the reason why that's beneficial is, well, once certificate's expired, it doesn't work anymore. So that means that if your laptop is compromised, or you lose a USB key with it on, or your hard drive is stolen, or your laptop is stolen, anything like that, the certificates that are on there are only good for a very short period of time. Once the 8 hours has expired, they can't be used to log in anymore. And unless they know other credentials, a password, have the access to the single sign-on provider, unless they can make Teleport authenticate them again, they can't get another certificate, which means that the servers are safe because they can't log in. A certificate, the other benefit of that is that it can contain a lot of other information which a standard public key can't. So I mentioned principals before, the concept of users being embedded into a certificate. So you can embed some information into this certificate which says you can log in as Ubuntu user, you can log in as EC2 user. That is extra information which can't be specified easily just by using a public key. So again, here's a summary of some of the things which you can see within a certificate. The nonce I mentioned before is the random ID which gets sent to the server to validate. Valid after and valid before, so certificates can only be valid within a narrow period of time, 8 hours, as I mentioned before. Another thing, so valid principals, list of host names, a list of usernames. You can also specify lists of servers that people should be allowed to log into if desired. And optional SSH extensions, for example, which can be ignored by the server already. So, mentioned the idea of single sign-on. What's a single sign-on provider? Well, something like Active Directory, for example, or LDAP, as we mentioned earlier, or any of these services here. They all offer, in many cases, single sign-on type authentication, and it can be easier to put all of your users in one place and control access from there, because then as an onboarding process for bringing new users onto the servers or for revoking access when users leave, that's easy to do because you've only got to do that in one place and it automatically cascades down to everything else. So this again is just a summary of what I was talking about before. The idea being you go to sign in, you get sent to an identity provider here if you're using one, says, tell me more about Bob, comes back and says Bob is a member of these groups. So now we'll go through a demo of Teleport. So that is the wrong window. Okay, so here is a cluster, a teleport cluster that I set up for the purposes of this demo. So it's called Webinar Main here. And this is the main login screen of Teleport. Teleport, as we mentioned before, does support the concept of local users. So you can you can set up a user locally, and you can have that information configured there. However, in this instance, we can also use a single sign-on provider, Auth0 here. So Gravitational, we're using Auth0 as our source of identity. So if I go to log on with Auth0 here, it'll ask me, how do you want to log in? You can log in with GitHub, or you can log in with Google. I'll choose Google here, and I'll use my Gravitational Google account. So when I click on that, I'm taken to the main Teleport front end. So this is a view of a cluster, the Webinar Main cluster within Teleport. And here we have 4 nodes listed. You can see the host name of each, you can see their address and the port that the server is listening on, and there are also optional labels which you can add in to add extra detail so that you know which server is which. This here is saying that they're just key value pairs. So this is saying the key here is environment and the value is demo. And that's the case for all of these. So you can also have dynamic commands such as kernel version or server uptime or similar. So if I go to log in, I have a drop-down list here of the users that I can use. Now, because I logged in as a Gravitational admin, I have root on this server. But I also have here gus.luxton, my name, and that's come through from Auth0. It's some extra data that's stored on Auth0's end, which says when this user logs in, he should be allowed to log into this server as gus.luxton as well. And that's configurable on Auth0's end, and then that can be assigned in Teleport to say, use this value to allow the user to log on. I'll go through that in a minute. So if I choose to log on as root, I'm given a session on the server. It's a standard terminal. I can do everything that I would normally do at a terminal. It works exactly the same way, with the benefit, of course, that all of these actions that I'm taking are being logged by Teleport during this time. So all of the connections that are being made, all of the text that's being entered, it's all logged by Teleport. So this is the web interface here, for example. When I'm done, I log out. Just press Control-D there to log out. Standard terminal command. You can click the X at the top left as well. And once I've done that, it will show here that this is me. I'm Gus at gravitational.com, my IP address, webinar node, duration a few seconds. And if I click on play, you see all the operations I just took. They're sped up slightly, but the actual timestamps are stored in the file as well. So it's sped up for quicker playback and easier playback. It's just like watching a video. When you drag to a certain point, it scoops you, it sends you back. You can skip to any point and see exactly what was going on at a given point in time and what was being typed. So that's how the web interface for Teleport works. I'll show you now how you can do this from the command line. So we have a command line tool called TSH. TSH is very similar to SSH. And if I run TSH login and go back to my browser window, it's popped up an extra browser window here saying, would you like to log in with Auth0 again? So I pick login with Google, and I use my Gravitational Google account, and we'll say login successful, go back to the product. So I switch back to my terminal window, and here we can see that I'm logged in as Gus at gravitational.com into the Webinar Main cluster. I have the cluster admin role, and I'm allowed, as before, to log in as either root or gus.luxton. And this certificate, as we mentioned, is a short-lived certificate. It's valid for 12 hours, and after that, I would need to log in again to do anything at all. So what I can do with this, I can get a similar view to what I had in the web interface. If I run TSH-ls for list, it shows me the nodes which are available in my cluster. Similar view to before. If I want to log into one of these, I run TSH-ssh root at webinar main Auth0. Very similar to the standard SSH command, but it just has TSH on the beginning. And then I'm given a shell on the server. We echo, this is the command line interface. I can install something like JQ, for example. And again, everything that I run here will be logged by Teleport and stored. So when I'm done, I log out again. Actually, yeah. What I can show you, in fact, is another feature of Teleport here where, so I have one session here on the right-hand side. This is my command line session. One of the other things I can do is while this session is going on, the play button here has actually changed to join. And if I click on join from the web end, it brings me into the same session. And everything that I run in the web interface is also echoed in the command line. So every command that I run in one side is also echoed in the other. This can be very useful for session sharing or training or similar, or just for having a second pair of eyes on a risky operation on a production server, for example, because even though the actions are logged and stored, sometimes it's best to have someone watching in real time. So that's something that's completely possible to do with Teleport as well. And when I disconnect, I still maintain my command line session here. So once I'm done, I log out. And as we can see, exactly what you'd expect will happen. The join button changes to play, and we get to see the full history of everything that I did during that session. And you can see the logs from both sides, everything that I typed in the web interface, everything I typed in the CLI, all of my typos, and everything that's wrong about that as well. So stores everything that you need. So as I mentioned, there are RBAC controls within Teleport. And one of the things you can do here is I have the cluster admin role. So you can edit the roles here. And what I've said here, as I said, when I log into a server, I can log in as either root or this value here. This says that I want to use the value coming through from auth0 called login. And it says external so that we know that that's coming from an external provider, which is auth0 here. And that is what gives me the gus.luxton login that I can use on these servers. I can also set up other rules. So I can say you should only be allowed to log into certain labels or certain nodes. So if you want to restrict people with a certain role from being able to log into all the servers, that's completely possible to do. As I said here, the standard length of the session that we're giving out here is 12 hours, and this is where that's configured. I could equally well change this down to 1 hour and save it, and when I issued a new certificate, it would only be valid for 1 hour. So I mentioned at the beginning Kubernetes integration as well. So one of the things I can do here is when I log into a cluster with TSH, I'm given the permissions, but also one of the other things that it does is it gives me a kubectl context, which is configured. So the idea here being that I can run commands against a Kubernetes cluster, for example. So if I run get pods in the webinar main namespace, this operation here actually goes via Teleport. We can see that here if I show this with the demo. So this actually hits a Kubernetes endpoint within the webinar cluster, and we get the response here, which comes back from Teleport that's actually been proxied through from the Kubernetes API server here. One of the reasons this is beneficial is because if you run a command where, for example, you want to get an interactive shell on one of the pods, this is very similar to an SSH command again. It allows me to do anything that I would be able to do. I'm logged in as root into the pod, so I could potentially take some damaging operations here or do anything that I like. But here's where the benefit of Teleport comes in. If I go back here, I have another session logged against the webinar auth main node. And what you can see is that, again, everything that I ran in that kubectl exec session is logged in exactly the same way as all my previous SSH sessions were. So that's an extra auditing benefit and something that can give you peace of mind to make sure that you know that no matter how people are accessing things, either via kubectl exec or by SSH, you've always got the information recorded and stored with access so that you can play it back later. So that's pretty much it for the demo. Does anybody have any questions?
Yeah, so there were a couple questions that came in. Let's go through that.
Sure.
And if you have any other questions, anybody who's on the webinar, if you have any other questions, please go ahead and pop them into the Q&A box, and we will also get to those. But let me get to the first two that we have. The first one is, can hosts automatically add themselves as targets in Teleport?
Yes, absolutely. So the way that you actually manage adding nodes with Teleport is so Teleport is split into three parts. It has the auth server, which handles authentication of users and nodes and the interaction with Auth0 or another SSO provider. You have the proxy, which is the web interface that I showed before. So that runs the web host for that and provides the services. And then you have the node service, which is the SSHD-like replacement that runs an agent, if you will, that runs on the nodes. And the way that you join a node is that on the auth server, you run a command to generate a new token to add a node. And then on the node, you give that token and provide the address of the auth server. So if you can configure long-lived tokens that will work for a day, a month, a year, however long you like. So if you issue a long-lived token, then you can use configuration management like Ansible or Puppet or SaltStack or whatever to put that token and the address of the auth server onto a node, or even something like Cloud Init with an EC2 instance and user data. You can make a server automatically join a Teleport cluster using that token when it joins. So yeah, absolutely possible.
Okay, great. And we have two other questions. One is, can Teleport be set up for local authentication for on-premises servers and simultaneously integrate with AWS or other cloud platforms?
Yes, absolutely. So the concept of clusters within Teleport is that generally you would try to group them according to your logical grouping. So what you could do in that instance you would have one on-premises cluster where you join all of your on-prem devices to, all of your on-prem servers, using the networking interface there. So you host that within a management area, for example, or a management subnet or VLAN, and you join your servers to that. And then you can also specify within Teleport the concept of trusted clusters. So you could set up another cluster separately in a management VPC in AWS or a regular VPC and join all your servers to that cluster. And then you can establish a relationship between those two clusters. So with your on-prem cluster, you can say you should trust the AWS cluster, and anyone who has the admin role on the on-prem cluster should also be given the on-prem, or should also be given the admin role in the EC2 or AWS cluster. So it's completely possible to do that, and it's the easiest way to do it, generally, we find. If you have a VPC peering with AWS, then maybe you could put everything in one cluster, but generally you're better off with separate clusters. But yes, you can absolutely link them together, and it can be used to handle both.
Okay, great. And there's one other question here. Let's go ahead and answer this. If there's no other questions, we'll wrap up. But if you have any other questions, now's the time to ask. You could also email us after this webinar at info@gravitational.com if you have anything else. But the question is, can Teleport work in agentless mode?
Yes, it can. So although I mentioned that there's a node service, an SSHD replacement or agent that you can run on a server, it is also possible to just run regular SSHD on the servers. There is a slight extra thing. When I mentioned before during the demo that you have to configure a server to trust the certificate authority for Teleport, that's what you would have to do with OpenSSH as well. So that works for things like embedded devices like switches or routers, which have an SSH daemon on them, but you can't run a third-party process. So there's some details in our admin manual about how to do that, but it's adding a value into your SSHD config and restarting SSHD. And once you have that certificate configured and you have the certificate available to that server, then yes, it can run exactly the same way, and you can use Teleport just like a Bastion server to proxy access through. So yeah, completely possible to run in agentless mode.
All right, terrific. I'm not seeing any other questions today. So thank you, Gus. That was a great demo, and thanks for going through the questions.
No problem.
We are recording this. I will send this out to everyone. Do email us at info@gravitational.com if you have any other questions. Teleport's available both as an open source edition as well as an enterprise edition. If you're interested in either of them, please download, come to gravitational.com/teleport and you can go ahead and sign up for a demo for the Enterprise Edition and get a 30-day evaluation of that, or download the open source edition and start using it.